So you may be thinking we're going to show you just another web portal that deploys a Linux virtual machine or even a Java web server running on Linux. That's the demo that all the other cloud providers show, not here. What you're going to see is an enterprise solution, a full-on demonstration of DevOps. As we develop the concepts of the storefront, the fulfillment orchestrator, the service managers, that architecture that I showed you earlier, we found that what we put together made for a very straightforward way to move development changes up the chain into production. And for those of you that are familiar with DevOps, that's essentially what it is. Any change a developer makes and commits to source control will automatically roll up to production with rigorous quality and security gates, and it does it all in minutes to hours. That's fine for a high-level definition, but how does this all work? Let's walk through an example to show you. First off, there's nothing. There's nothing in the system for our Java developer. They have to visit the web store and order the DevOps pipeline before they can begin. And what you're seeing here is that order. We're doing it in ServiceNow because that's our storefront. All they need to do is place the DevOps pipeline in their cart and order it. And don't worry, we'll have all the right approval in place before the environment is created. So after the DevOps pipeline is ordered and approved, the fulfillment orchestrator is contacted and it takes it from there. And this is just a quick look at our fulfillment orchestrator. It's CA Process Automation Manager. Nothing too flashy, just connecting a bunch of operators together. But as it operates into the background, it's the heavy lifter of this system. Now the first thing the fulfillment orchestrator does is reach into the source control system and create the project. It even goes further, placing a fully functioning and meaningful sample for the developer to start from in the DevOps pipeline. Then the orchestrator reaches into our automated peer review system to point it to this new Java Web Service project. More on this automated peer review system later. It's very cool. After that, a build job is created by the orchestrator in our automated build system. We use Jenkins for our build system. If you've not heard of it, it's a broadly used tool that automatically builds just about anything from source control. And furthering the automation chain, we hook Jenkins up to our quality control tool, which is able to scan code and tell us how good it is, see how unit tests are run, those sort of things. In this example, you're seeing Sonar, but we can throw a number of quality tools at it. So as you've seen, we're not even a minute or two into the demo. We've already pulled a lot of stuff together that used to have to be manually done. And that's it for the order. The Java developer is now able to go forth. They can point their Eclipse development environment at the source control system and make changes to the code as they desire. If the developer commits code to the source control, an amazing process is started. Actually, people seeing DevOps for the first time describe something like this as staggering, astonishing, or just plain awesome. And hopefully you will too. Keep in mind that this code change can roll all the way up to production. It'll come from the developer's editing environment, go into our development testing sandbox, roll through a few phases, and get all the way up to production as a high-quality, trusted business service. So the source code is committed. Then the automated peer review system notices and goes into action. It puts the code commit into code purgatory until all checks are complete. And one of the coolest things about the peer review system that you're seeing here is that robots can be peers too. So in addition to a traditional review of a change from a peer or a lead on the development team, a build robot can review the code change too before anybody sees it, removing a lot of unnecessary work of reviewing code that didn't compile in the first place. So the automated system gets first crack because we don't want to bother any peers with a bad change. The system then takes the Java code, compiles it, turns it into runnable code. Unit tests are performed on the runnable code, and code quality is run against it. If the code doesn't compile, quality isn't good, the commit is then thrown back to the developer to fix. But if the code is compiled, unit test coverage is good, and all the quality indicators are high enough, the Java Web Service runtime artifacts are put into our artifact repository, and the code can move on to the next step. This next step is where cloud comes back into the picture, and it's powerful. It's a Java Web Service that got changed, so built into the lifecycle is the ability to deploy the Java Web Service in a real live test environment, all the way eventually up to production with proper gated approval. For the sake of brevity, we're just going to look at the development sandbox But keep in mind that each environment up to production looks a lot like the development sandbox. It just gets bigger and more well governed. So the runnable code is put in our artifact repository after it is successfully built and quality scans are run against it. And now the fulfillment orchestrator goes into action and deploys and tests the Java Web Service. First off, it reaches into our VMware environment and starts the servers that make up the Java Web Service environment. By the way, this looks a lot like production, even in the development sandbox, like I said earlier. After the VMware server environment is started, which by the way, most cloud demos stop here at this creation of the server environment, but not us. After the environment is started, the runnable Java Web Service code is pulled from the artifact repository and placed in the server environment. Now it's ready for as many tests as we want to throw at it. We'll show you just 2 tests here, testing the Java Web Service and testing the user interface that uses the Java Web Service. We can also do many other things as we move up the chain to production, like security scans, capacity tests, stress tests, many others. But we'll just test the user interface in the web service here in the development sandbox. So the orchestrator has a running web service now. That's the thing that used to take at least 35 days to get up and going, if you remember earlier in the presentation. It was started in minutes, and now the orchestrator is going to run the tests. Here you're seeing a couple of ways to test the project. This first one is HP functional tests being run automatically by the fulfillment orchestrator, and it loops through all the test cases that are in source control and executes them against the user interface. Next, our Lisa testing tool takes over and does the same thing, pulling the tests from source control and testing all the web services in the project. Best of all, no special test environments need to be created by hand. This sucks up tremendous amounts of resources in an enterprise with traditional means. Not in the cloud. Testing environments go and come as we need them automatically. Very cool. So that wraps up the demo. You've seen how a developer can change code in the code repository, and then minutes later, it's automatically built, quality is assured, and it's deployed and tested in a live environment to make sure everything works according to plan. This happened in the development sandbox in the demo, but it can easily happen in environments like integration test, user acceptance test, and even production. You'll get a different definition of DevOps from a lot of different folks, but in this demonstration, with cloud as the powerhouse, you just saw it in action. Magic? Nope. Just a lot of hard work to present the right catalog item in the storefront, design the fulfillment orchestration processes for that catalog item, and to appropriately use individual service managers in the right way.